Hello everyone, I'm Alan, aka Chita, and ignore that. And today I will be analyzing the VB version of the COMP1 AQA programming exam pre-release. So as I said, I'm using the VB version. I'm using VB 2010. But it really doesn't matter which version of Visual Studio you're using. Alright, so I've just loaded the code in, and I placed the text file on the debug folder so we can run. And the only thing missing before I can actually run the program is change this from module 1 to card predict. Save, and we can run now. And there we go. So as I said, you can enter option 1 and it finds the card, and we can actually play the game. Alright, so first of all, what I like doing when I start a new program is to dry run from the submain, because that will be the first thing that the computer will actually do once you run the program. So the first things that happen is these three variable declarations, and then we have the randomize. Now if you don't know about it, randomize is a function that allows for you to use the R&D function, which just generates random numbers, which is used later on in the code. As I said, I haven't changed anything in the code yet. So we've got the choice, which is a character variable, and then two variables which are of user-defined data types or structures. Both of them being arrays. Now, if you read the preliminary material, you'll notice that it says that if the language that you're using allows for index 0 on arrays, the index 0 is ignored. So in here we have an array of maximum index 52, which means 53 elements, with the first one, the element 0, being ignored. And over here we got the same thing with 3 instead. Alright, so those variables are declared, the randomize function is initialized, and then we go to the first loop. On the first loop, the first thing that happens is display menu, which is just a procedure that will print a bunch of lines. So it's just console.write line. And then we got choice is equal GetMenuChoice. Now, not to be confused with GetChoiceFromUser, or however it's called, I can't quite remember right now. Yeah, here, GetChoiceFromUser. We got GetMenuChoice, which is a function. They're both very similar, but they're used in different areas. Ideally, you wouldn't use two different ones, but that's how AQA did, so that's what we're going to do. Now that is the first time that we'll actually make a variable. So the first time that I want to make a change in the code is that the function is a function of char, so we will return a single character, which will be saved into a char variable again. Now, if you notice here, we use console.readLine, which allows you to enter as many characters as you want. Now let's run the program, and I can just keep on typing as many words or in many characters, and whatever character I type in, it will take. Now what will happen is it will only consider the first character, just because that's how VB works, although that's not really user friendly. Just the fact that you ask for a single character and you can type in as many as you want, it's not really the most ideal way to program. Obviously the first character being entered was G, and G is not a valid option. So let's quit that and let's start making some changes. So the function already returns a char, so we don't need to worry about that, and we're going to change this. Instead of read line, let's change to read key dot key char. This means that, let's run the program, and as soon as I press the very first key on the keyboard, it will write, and from the moment that I release my finger from the key, it will immediately go to the next line. You don't actually need to press the enter key. This means that, you know, if you press enter, obviously it will be empty and you just outputting nothing. But if you press something like T, as soon as I press T, if you hold down, it just keeps on doing it. But as soon as you press the key, it already goes to the next line, so you don't even actually need to release the key. So I don't know if you notice over here, I pressed E now, and we'll try to do it and can't do anything. Now let's press 1, and 1 works. Now that at that point is a different procedure that which will do something similar. Let's quit. So let's make a. It's always good to make a bunch of comments, and the way that I like doing is I press tab a few times, and then I start the comment and I write the comment with caps on, so it's easier for me to see what I did, where I did stuff. So if I make here changed class. Okay. Now let's go back to the main, and choice is equal GetMenuChoice. Then we go to select case. Select case choice. Now if choice is 1, we'll execute that. Okay. If choice is 2, we'll execute that. 3 that, and 4. However, what happens if the option selected it's not one of the many options listed in there? Then ideally, and what sometimes they ask you to implement on the actual exam, is an error message that will display in case you enter something that's not a valid option. So if you do use input anything else, and funny enough, case else is what we're going to do. Case else, and then we can simply put console.writeLine invalid option. Please try again. And once again, we added this case else. Now instead of having to add a comment saying chain, well, this case is added really. Instead of adding a comment for each one of the things, I know that if I added a case else, then everything that was under case else must have been added as well. So, you know, just using a bit of logic saves us time. Now I'll just run before I do the next thing, just so the next thing makes sense. So if you type 1, works just fine. Let's just try to, oh, caps on still on. Okay, enter your name, just empty. Okay. Now we checked for valid input and it was working just fine. Now let's check for something else like T. Select an option T, and over here we got invalid option, please try again. Our error message. Now you probably noticed it took me some time to find where this was, because the console is not clear and you keep putting stuff in. So what we can do is right over here, before we display the menu, we just clear the console. Clear, and we want to add that. Try to keep them on the same level. Added, and screw it. That seems the same level. Okay. So we clear the console, but that won't be enough, because if I do that, it will display that and immediately it will clear the console, because it's a loop. You write this, and then we'll come here and say loop until that. So we'll go back to here, and the first thing is clear, console.clear. So what we want to do is, I am actually going to make a sub for that, because that's something that we're probably going to use often enough to make sense to actually make a whole sub just for that. So let's make here sub, get rid of caps, pause program. Don't need any parameters or anything, and as always add, oh, that's a bit much. Could you please go in the same line? There we go. Most of the video will be me trying to get these comments at the right level. Alright, so what I'm going to do is I'm going to first tell the user that the program is paused. So just make a full space, console.writeLine. Alright, so what we're going to write, first of all, I am going to use the carriage return VBCRLF that simply makes an empty line, so it skips a line, and then we're going to write press any key to continue, and that should be enough. Now the user will know that the program is paused, and will know what they have to do in order to unpause the program, in order to continue using the program. And then we need to pause the program. So again, console.readKey. Alright, now that's very simple and everything's nice. In some cases, when I'm doing some programs, I also like to console.clear over there after the user pauses, but the problem is that we might not need that every time we pause the program. If later on I decide that we are actually using it, we're actually clearing the console every time we pause the program, because if we decide to pause the program not from here, we won't have this to clear the console. If that's the case, then I will add it in here, and I will pause the program after each option. Alright, so let's check it. Now, for valid options we checked and it's still working, we didn't change anything for that. And let's try P. Invalid option, please press any key to continue. And there we go. Now let's quit. Okay. Now, I was actually trying to avoid and I forgot about it. If you press key, Q, if you try to quit by typing Q in, the problem is that Q is not one of the options, selects case, so it goes under the case else. So it actually says it's invalid input. We don't want that, and I'm going to add here something that I really like doing just for fun. Sub ByeBye. Just really, you shouldn't really waste your time doing that, but I like doing that. So basically, what I like doing is just make a nice stickman waving goodbye for you. Just because normally you need to add the case Q just so you don't have the invalid option error message displaying. So might as well. So what I like doing is console.writeLine. Then I'm going to write stickman. Like that. Oop, forgot to close. And now we're going to pause the program. System.ready.thread.sleep. And don't worry about that. That's, as I said, that's just Vanity. So just copy that now. Once more. And let's repeat that. Now come here. And ByeBye. I'll just make a comment here that's just Vanity. And let's see. Hope I spelled it right. Just copy this. Not here, here. There we go. Vanity. So, if you're curious about it, this simply pause the program for the integer number that you enter in milliseconds. So about a quarter of a second. Yeah, a quarter of a second. Because 1,000, if you enter 1,000, it will pause for a whole second. I probably want these a bit longer so the person can see. Let's make 300. Alright. So caps on. That's something actually that I forgot to do. Oh. Console.clear. Let's pretend that I added that before. And that should be enough. And we want to clear it as well on the start. There we go. Alright, now I was with caps on and I tried to enter a valid option Q, and it didn't let because it is case sensitive. So if we go to GetMenuChoice, all we have to do over here is lcase open bracket, just close over here, I'll fix it like that. Okay, so that's changed, saved, and now it will work. I'm not going to bother you just by running it again. Lcase will just make it lowercase and it'll work. Just get my word for it. Right, now we solved pretty much everything for this. We solved this, and the program is paused, and we're clearing the console. So now we're ready to actually go for the functionality of the program, which is where the fun starts. Now let's go in order. So option 1, I'll just add this to comment here. Let's play game with shuffle, so we'll just do shuffle. Right, now first thing, load. Now if you click, just a tip for you, if you click on the call of a procedural function and then you type in F12, it takes you straight away for the where you declare the thing. Problem is that F12 is also the, there we go. Oh, there we go. We don't want the FPS. Let me just disable that quickly. There we go. Alright, now LoadDeck. What does it do? Declares a variable and then it opens a file. It gives the number file1, which will be the file name deck.txt, which since there isn't any directories in there, it will just go straight on the debug folder, which is that where you're actually running the program from. And the open mode is input, which means you're actually reading from the file. Alright, now count is equal 1. That will be the line that you're reading from. Well, not the line, sorry, that will be the card that you're reading from, because each card will take 2 lines because of the way that they do that. Now while not EOF, while not end of string, end of file, which file? File1. What does it do? Deck index count dot suit. Now deck is a parameter, which is the variable declared on the main folder, which is the actual deck. Oh, surprise, surprise! They use the same name. So the first line that's read will be deck1 dot suit because the index 0 is ignored, and the second line will be deck1 dot rank. This is just to convert to integer. That's the actual read line statement from the file. And then after it gets the first 2 and increment the first 2 lines from the file, increments the count by 1, and then it keeps looping this until the end of the file. And then at the end it closes. Looking at it, apart from actually placing the text file on the correct debug folder, or actually adding the directory where you saved, if you want it to be on C, you put C column slash, but we don't want that because I already placed it in there and it's working. Right, so not really much to do over here. Let's go back to, I'll just scroll up. Main, okay, so ShuffleDeck. Now this is a pretty interesting procedure. ShuffleDeck. What does it do? First of all, it has a parameter, which is deck. Again, it's the actual deck. so the positions on each card on the array. Then we got numbers of swaps, which is an integer. Position 1 and position 2 is an integer. And finally swap space, which is basically a follower or temporary variable. It kinda has the role of both. And finally we got the number of swaps made so far, which keeps track of how many swaps we've done, and that's the total number of swaps. It feels a bit strange to have it as a variable, because it doesn't actually change ever. So it would make sense to make it as a constant. The reason I'm not going to do it is because if AQA didn't do it, is because they might ask a question about it. Could be a question, what is the role of this variable, which the correct answer would be fixed value, because you get the value once and you'd never change it again. Or it could be for possible improvement, which it might change. It might have this number random. Well, we'll think about it in a future video. That will be just this video, just analyzing, fixing a few things. So, for number of swaps made so far, that's the long named variable, to number of swaps. Position 1 will generate a random number. This function generates a random single value. So it will be a number from, I believe, 0.01. I'm not sure 0 is actually starts anywhere to 1.0. So that's the R&D function that will return that. So what they do is that they times it by 52 and they convert it to integer, because otherwise you have a conversion error, which is something very annoying to deal with, and they add 1. Now you can check it online. This means that is the upper boundary and that's the lower boundary, I believe. Either way, that would make sense, because those are the things I normally, when I need to do those sort of things, I always check online. MSTN has a very nice explanation for an equation similar like that. The one I use is a bit different, but that works as well, so that's fine. So basically what it's doing is that it's generating two numbers, two positions in the deck, any number between 1 and 52. Now these numbers will be used as the index number on the deck array, and it will swap. So we'll swap them, and this is done 1,000 times. Now if you think about it, there are 52 cards in the deck, and if you had the deck in your hand and you were to manually shuffle it, you normally split it in the half-ish and you pile them together, so a bunch of cards will swap. So basically you're swapping 52 cards ish. Let's assume you make a perfect swap and you manage to swap the position of all 52 cards. So if you do, let's get the calculator. Let's get the maths here. So, you know what? No, forget about it. I'm not gonna do it. I might make a mistake and embarrass myself. So basically, what does that mean is that each card that you swap counts in 1 for this 1,000. I remember that on my class when we were checking it, that a lot of people thought that 1,000 was a ridiculously large number, but as a matter of fact, it's not too far off. It is perhaps a bit too large, but because of the way that this works, it makes sense to have a large number. It's better to have it over shuffled than not shuffled enough. But basically, every time you shuffle the whole deck once, which basically you do a whole deck at a time, you're doing about 100-ish swaps, give or take. Well, if you do a perfect swap, you're doing 104, but nobody ever do a perfect swap. There's always that 1 or 2 cards that remain in the same position. So, you know, let's just make 100 to be easier to calculate as well. So 1,000 times about 10 times that you split the card into half and put it. And normally you use like, I don't know, 6-7 times if you want it to be very well shuffled. So 1,000, I thought, was a pretty good number. It's, Doesn't really matter so much. You could make this number lower, but why would you? Because that's what AQA gave you. Alright, so it generates these two, and every time it loops it generates new two numbers in here, which are then used again for the index, and we use this variable to hold position 1, the value of position 1, and then that's outputted into DAC, which is a ByeBye. So it is actually saved on the memory location, so the changes are saved. Now let's go back to the main. Starting to be a bit tiring. Again, we don't have to change anything over there, and then we go to the PlayGame. We're getting to the point that we will make some changes again. PlayGame. There's a bunch of variables. I'm not going to go through them right now. I'll make a separate video about each variable and their roles. The ones that are most important is this game over, because it's part of the main game loop, and the number of cards turned. Okay, let's go. That's a do while loop, which on VB you can also just put a while loop, and that works. While you haven't turned yet 52 cards, and the game is not over yet, because you put and not game over. If game over is equal true, not becomes false, so that's fine. So the game would stop once this whole thing outputs false. If the game's not over yet, this is false. Not over false becomes true. That's what it's doing. Now get card, next card, deck, number of cards turned over. This is used in here as well. In fact, I think it's easier for me to explain over here. Get card. It's last card. It's basically the first card turned over, or the card that you have turned over right now, the card that you can see, which is taken from the deck, and that's the position. Position 0. The way that it works on this case, 0 is the number to be sent for the first card. Okay, I won't go into details on this yet. It just, as long as you understand what that does, you'll be fine. Then display the card, last card. So as I said, last card will always hold the card that you are able to see. So we display that to the user, so the user knows, and then number of card turns over becomes 1, because we turn over one card, and then 1 is less than 52, so we start the loop, and we do it again. Now this, I was very surprised when I saw that. This is a validation, which is probably one of the first times the AQA actually makes a validation on the pre-release code. What does that do is that while you don't have a valid choice entered by the user, you'll ask it again. You won't bug the program doing that. It's not the best validation, I would say, because let's go there and make this change. So we got these, and we're going to change here. So read key dot C#, and once again I forgot case close, and let's make our comments more. Yeah, I think that's right. Changed space. Alright, now let's go back to PlayGame. Well, I'm not going to run it to show, because that's the exact same thing as I did before. You just only take one character at a time and you move on. Now this already does the validation, so we don't need to select case or anything. Okay. Not this. I was looking, that doesn't look right. This already does the This already does the validation, and you can just move on from there. Now what we'll do is display card, next card. Once you get your answer, you'll say which card it was, and number of cards turned over will be that. You know what, it's been a long time since we ran the program. Let's run it again and have a look. Let's go for 1. card is 1 of hearts. So, sorry, not 1. It's 8 of hearts. I think I'm getting a bit tired now. So the card's 8 of hearts. What will we do? 8 of hearts is pretty high, so I assume that it will not be higher. So let's go no. Well done, success, yay! Card's the 4 of hearts, so it displays. What it does is it displays the next card, and then it tells you if you're right or not. So now my score is 1. Do you think the card? So we know the card from here. Now let's quit it again. And where were we? We were here. Now number of cards I'm over is equal to number of cards I'm over plus 1. So we increment that. That's the stepper. And then we got this function which will output a boolean value, which will say if the card is higher or not. So the program knows if the next card is higher or lower, well, is higher or not, if with the current card they have faced up now. Now, if the card is higher and choice is yes, you don't actually need these brackets because AND has priority over OR. Well, I like putting it because it becomes very easy to see. After all, this is a Boolean expression. Now, if car is higher and you enter choice yes, or if car is lower, so not higher, and choice is no, which means the two possible ways that you can be right, display correct guess message. Just I find a bit odd the way that they do it, but fine. And then last card becomes next card, which means that you turn the card around, and now that's the card that you have facing up. That's the card you can see, and then you, if not, so if you're wrong, if this is not true, then the game is over, and you stop looping because of this. And it will check, is game over? No. Is the number of cards turned lower than 52? Which means, is there still any cards to turn around? Yes. Then loop again. No. Next line. If game over, which means that if you finish if you stop looping because you got a message, because you got a card wrong, then we'll display end of game message with number of card -2. Which basically means you didn't get the current card that you were at, so the card that you got wrong is deducted, plus the card that you were before is deducted. That's why the -2. And update the recent score, because the recent score keeps track of the actual score, and this would be your actual score. Again, not the best way to do it, but oh well. If the game over is not true, just to say that this loop stopped because you reach 52, you display end of game message 51, which is the highest possible score that you could get, and you update the recent score with 51. That's the whole game. The other 3 options is let's go back up. So we got this one, which is pretty much this without shuffling the deck. So everything works the same way except you skip this. And then this very simple procedures that will simply display a bunch of stuff that you have saved in here somewhere in the game, in the procedure. Can't quite remember right now. And to be honest, I'm tired, so I'm going to stop this video right here, and next video we'll probably have a look into variables. So thank you for watching. If you like, feel free to click like or leave a comment. If you have any idea of possible improvements for the game, please leave a comment below. I'll check it, because after I make a video on variables, I will most likely make a video on I'll start making videos on improvements. I might make a bunch of improvements at once. I might make them separately. I'll see. But either way, the more comments, the more ideas that you guys have, the better prepared we will all be for our exams. Which, after all, that's the reason that I'm doing that. Just prepare for our exams. So again, thank you for watching, and I'll see you next time.